All right, let's go ahead and get started. Thanks for joining us today for the Real Time Weekly show. My name's Aaron Syme. I'm editor of Real Time Weekly, and I'll be your host for this live conversation about WebRTC analytics and monitoring. Joining me today is Varun Singh, the CEO and co-founder of Callstats.io, which is a service for gathering and analyzing data about the quality of your WebRTC applications. Varun's going to tell us more about Callstats and share some of what they've learned about WebRTC quality. So thanks for joining us, Varun. Thanks for being here.
Hi, Aaron. Thanks for inviting me. Look forward to the event.
Our pleasure. So before we get started, I should just mention a couple of things about sponsors. The Real Time Weekly show is sponsored by WebRTC.Ventures. Our team at WebRTC.Ventures provides complete design and development of WebRTC apps. So if you're interested in learning more about that, please check us out at WebRTC.Ventures. And I also want to make sure that you know about Real Time Weekly. We're a free weekly newsletter covering a variety of technical topics of interest to developers building the next generation of real-time applications, including WebRTC and other technologies as well. You can sign up for free at realtimeweekly.co. So let me quickly introduce Varun to you, our guest today. Varun is CEO and co-founder of Callstats.io. You can find him on Twitter at Callstats.io. And he has a PhD from Aalto University in Finland, where he worked on algorithms for congestion control, for video telephony, and video streaming. He's also an IETF W3C contributor. And as part of his university research, as well as in his professional career, he's collaborated with many industry partners such as Nokia, Cisco, Ericsson, Fraunhofer HHI, and others. So a lot of interesting experience relevant to today's conversation, and no surprise that you parlayed that into starting Callstats. So thanks again for joining us live today, Varun.
Thank you.
Let's start by having you tell us a little bit more about Callstats, and I'm going to turn off my screen sharing, and you can share yours.
Sure. I'll just
tell us a little bit more about Callstats, what it is, and how does it work?
Sure. Callstats.io is WebRTC analytics in the cloud. And with a few lines of JavaScript code, you can integrate Callstats into any WebRTC web app. For example, this one that we're currently using. So what we do with WebRTC, based on the WebRTC Statistics API, which I am co-authoring with Harold Alvastran from Google. He and I worked on this a couple of years now, and we've just pulled out a new draft a couple of weeks ago. As WebRTC matures, this draft will also mature based on implementation guidance from folks developing WebRTC. So today, Callstats.io is the first cloud-based monitoring and management service. We started about a year and a half ago with a couple of beta customers. Since late last year, when we announced the developer plan and the enterprise plan, we've seen a steady growth in customers. Today, we have about 250 deployments of Callstats.io around the world. And a few weeks ago, we are now available or deployed on all 5 continents or 6, depending on how you count them. So we have in Australia, in Africa, and in South America as well. So it's exciting times for us. So over the last year, and more importantly, the last 6 or 8 months, we've seen a heavy an increased growth in WebRTC, both within and outside in the ecosystem. And some of the things that we've observed, we'll get to in the later part of the presentation, some numbers. That always gets people excited. And the initial part, we'll talk about like why we do this and what made us build this system a few years ago. So today, we have a bunch of integrations with platforms. If you write your own JavaScript, WebRTC JavaScript SDK, or or your own app, you can do that with 5 steps. But if you use one of the existing platforms, then with a couple of lines of code, you should be able to get this integrated in your pre-existing app. So we have Twilio, Jitsi, WebRTC, Timesys, and Pexip, for example. These are the ones that we can publicly speak about. And if people who are building their own SDKs, if they want to get an integration with Callstats, they can write into us, and we'll look forward to working with them. So typically how WebRTC measurement works is that in our case, since we're a web app, we're basically deployed on WebRTC web apps. There's a CSJS or Callstats JavaScript library, which is integrated into the WebRTC app directly. And here you can see that we reuse the functionalities from WebRTC. So we listen to a lot of handlers, a lot of events, including the getStats API. Which both the application and Callstats can listen to. And we collect data at regular intervals at the beginning of the call more often. As the call approaches like a steady state, let's say 3, 4, 5 minutes into the call, we start to collect data less often and sending it to Callstatsio. So typically you would see in the first 300 seconds, something like about 100 samples, and then over time you would see fewer samples. And if something happens in the call, for example, like suddenly the audio gets blown out or video, then we collect more data again. So it's more opportunistic in that sense. So this is the infrastructure. Basically, we get data from each endpoint into Callstatsio, and this is similar to what people could build by themselves as well. So we use the existing APIs. We know that some people collect data at the end of the call. They collect a slew of data, and towards the end of the call, when the person terminates, they try to send data then. We, on the other hand, collect data more throughout the call. So why do we collect the data during the call and more opportunistically is because of this cartoon that we saw a couple of years ago, and it resonates very well with us. The fact that WebRTC is built on real-time communication stack. You expect the conversation to be fluid. And when the conversation is not fluid, a lot of people spend a lot of their time trying to diagnose that. And when those situations happen, you prefer to have more data than less data. So this is why we do Callstatsio, and this is why we measure and collect data in real time. A lot of people, when they talk about WebRTC, they spend a lot more time on talking about codecs and how they would have higher quality, which is typically translates to higher throughputs. For example, people talk about 4K to 1080p, but for a conversation to be really interactive, you want the latency to be low, right? And so, for example, this is a call, just a random one from our data set, where we see this is an audio only call and it's an RTT. So you can divide the numbers by 2 to see what would be the one-way latency. But you see peaks of about 3 seconds and both ways, right? So they're correlated peaks in this case. So both sides are sending audio, and you can see blurps of latency every 10, 20 seconds. And towards the end of the call, you start to see these peaks emerge more often. So we did this a couple of years ago when we were building something else, and we noticed this was happening a lot, and we started to measure this. And Callstatsio basically came from that experience of building a kind of WebRTC product and realizing that there's a lot more desired in terms of analytics. It's not just about collecting data, it's about visualizing, interpreting it, and so on and so forth. So that gets us into the next part. And I believe that anyone who's building a WebRTC application cares a lot about these metrics. So when we build any kind of measurement platform, you ought to know what to measure. And in our case, we basically say that there are 3 types of things you want to measure. One is the network metrics. This is typically very well known. You want to know bits per second, RTT, jitter, packet loss, so on and so forth. And then there's the multimedia pipeline metrics, such as playout delay, frame metrics. You want to know in terms of timeliness if data is being rendered correctly or not, and if people are hearing what you're saying or not. So both in terms of a liveliness check. And that comes into like modeling quality based on those metrics. And we'll get to this in a bit as well. And overall, I believe apart from these network and multimedia metrics, you want to measure annoyances. And in our case, we talk about annoyances in terms of failures where you suddenly call drops or a person redials into a call. Or, for example, the frame rate or resolution changes and you have pixelation, for example. So all these are annoyances that the user perceives, and we try to like measure those aspects and then quantify that into a metric. And we have several metrics internally, and we use one which is called objective quality, which takes both the timeliness of media playout and the spatial visualization of media, both of these numbers, and compounds them to make a quality metric out of it. Above all, we also allow from our API to gather user feedback. So you can get, based on what questions you ask from the end user, feedback from them. And that plays tightly with the objective quality, because we can take the ground truth and verify that with the models that we have, and we see if there's correlation between like what the user observed and what the algorithms themselves observed for those entities. That being said, so there are typically two types of metrics. One is service level metrics. This is if you run a service which is deployed to hundreds or thousands of users, they use it, and you want to know like how many calls were made on a day, what is the average average duration of the call, was it shorter than you expected, longer than you expected, has it varied over time, and so on and so forth. So these are not typically, these are aggregate metrics over a conference period, and not necessarily of a particular conference. And then there is conference timeline, which is of a particular conference. So if you know, for example, a call was bad because it was reported by someone, or because you were looking for them because Callstatsio sent a notification, or your signaling said there was something wrong with this call because there was a lot of churn, there were a lot of people rejoining the call, then you can go and look at it. Typically, we show this data both from a high-level point of view, so you can see how many people were on the call, what kind of end systems they used, what type of networks they were on, did they use IPv4 or v6, so on and so forth. And we also have an event timeline where we overlay actions that they may have encountered. So this might be that they've muted their microphone, or paused their video, changed to screen sharing. We also have new events like dominant speakers and so on and so forth here. So you can see there's something called disrupted, and we'll come to that in a moment as well. But since we collect data, you can also correlate the events with, for example, what happened on the network, or the quality or the media level. So you can see when the frame rates changed, when the bit rates changed, when the latency changed. So you can dig deeper into like every aspect of the call. So you can correlate, for example, in this case, to user Doc and Marty. You can see like how their quality changed over a period of time. So as I said, we measure something called disruption, and in this case, disruption is loss in connectivity, either when a network interface changes. So for example, you go from 3G to Wi-Fi or vice versa, or you have low available capacity because you walked out of the door and suddenly you lost connectivity to something, or you have high delay because there's other people in the household which suddenly turn on either YouTube or like start doing BitTorrent or something similar, right? So there you have interaction with other flows in your network. In this case, what we show is like third person, which is in the bottom, has a disruption with one of the users for like 8 minutes period. So if you get a call from, or if you get a support ticket from a customer which is complaining about bad quality, you kind of know when it happened, on how long that outage was, like how long was he impacted by that outage. But since we measure disruptions, we also gather user events, we can see how disruptions and user behavior correlate. So for example, we've seen in the past, whenever we had disruptions, end users toggle their audio, video, or turn it on, turn it off as a method to figure out if they can solve this issue without reloading the page or like sending a customer request or a support request. So we see that whenever there's disruption, some users change, either turn off their video, hoping that they get better audio quality. So that comes to our last part of our talk, which is about the state of WebRTC as we observe it. So this is a very important caveat. This is what we see and not necessarily what other people observe. This is also based on the fact that we monitor a large, diverse environment. So there are platforms as a service which are very well managed, and there are some people who have rolled out their own platforms or their own services. So it's a mixture and a combination of those things. So sometimes we see very strange results as aggregated, but this is the state as we see it. So a lot of people talk about WebRTC and the growth of WebRTC calls. So for example, 11% of our calls are legacy interconnect. So this is either to a phone or via an asterisk or PBX or something similar. And 45% of the rest of the calls are peer-to-peer, so just two participants. And another 45%, or roughly 45%, is greater than two, so three or more participants in a call. So we do see an emergence of this multi-party, and it's growing. Typically, we see around 4 to 5 people in a call, and I think I would say something like the largest ones we've seen are about 20, 30 people. So the numbers are increasing, and there are people who are pushing the WebRTC environments as well. When we talk about a lot of networking stuff, we always run into is that IPv6, right? So we talk about IPv4 exhaustion, and if the new services are needed, how much of that would require IPv6. So we do see that about 72% of the calls that we observe happen over IPv4. At 26% of the calls have both v4 and v6, and they may switch between the two or only use v4. Although we do see about 90% or more of the calls prefer v4 addresses. And we have about 2% of the calls which are only IPv6. And this may happen if the IPv4 or DHCP v4 kind of like blows away for a moment, then people just have v6 addresses, and they might start their calls at that time. When we do ICE candidates, we see this is both. So this happens when we try to set up a call. You exchange a bunch of candidates. Typically, we see about 5 to 8 candidates. That's fine. This means that people have either two interfaces like wireless LAN and 3G, and typically v4, v6. But sometimes we see 20 candidates, which may lead to a longer setup time, for example. So leading that into setup time, when we see majority of our calls set up in less than 5 seconds, and that's reasonable for people to expect that they press a button and within 5 seconds someone shows up. And there are about 25% of the calls which take more than 5 seconds, and some of them take more than 10 seconds. And this may also be for the fact that the most of the systems that we are monitoring are based in JavaScript and web, where people kind of are not very interactive. They press a button and lean back a little bit, wait for things to happen. If we were monitoring mobile, we would perhaps see the skew towards like shorter calls, mainly because people do not keep hanging back, not looking at the screen. So if they press a button, they would expect a reasonable response time for that. Since we measure across different diverse platforms, we see that 24% of the calls go through turn and relay. And this is including everything from enterprise all the way to home consumer products. So 76% of the calls require no relays, or stun is enough. And 16% of the 24 require just a UDP. It's the last 8% which requires some kind of TCP. And we've been pushing harder for our customers to deploy deploy this in an attempt to lower the failure rates that some of them have been experiencing, because without the TCP relays, they might find them a lot of their calls in some scenarios may just fail to happen. And this leads us to the next question, which is what is the failure rates we see? And I remember a couple of months ago, I think it was at Enterprise Connect, I said there were 12% call failures, and about, I think, around Twilio Signal, where I gave a talk as well, we reported about 8-9% call failures. And today I'm saying that number from 12% has diminished to about 4%. In the same period, we've onboarded more customers, as you saw from the previous slide. We've got the traffic has increased or doubled in that period. So it's not a fair comparison, like 12% reducing to 4%. But in the sense that I think there's also maturity in the ecosystem where people have looked at the numbers and responded by making their platforms more robust. So it's a step in the right direction. The worst would have been if even after 6 months, we would have seen 12% call failure. So I think that's fair to say that things are improving. So I did say 4% failure rates. We do still see 85% of them are connectivity failures, and this may happen for various reasons, including turn and firewalls. But about 14-15% happen when they fail to get access to media. We have an explicit callback which captures it. This may happen that the user did not want to give access to their camera as well, or they do not have access to a camera at that point. So there's various reasons why get user media may throw an error, including the fact that they do not want to give permission. We also talked a bit about call reestablishment a couple of months ago. These numbers change over time. So about 80% of the call reestablishments are due to connectivity things related. So in some cases, 49% of the calls, we did lose connectivity, or we don't know any more than the fact that we lost connectivity. In 12 to 18% of the cases, we've diagnosed these to be because of high delay. So periods just before the call dropped, we saw periods of 90 or 100% packet loss for tens of seconds, and the same thing for delay, that we saw extended periods of like 3 or 5 or 10 seconds RTTs. This may happen because either they walked out of the room and lost some connectivity, or there was something else that happened on the network. And about 20% of the calls in some cases are due to one-way audio video. So people get on, everything is looking fine, they don't hear anyone, and then they press redial or reload the page. Since no talk would be complete without some network metrics, so we put in one, which is round trip times. In this case, we see that about 80% of the calls have less than 400 milliseconds of RTT, which is actually pretty good given our geographical spread and the way some of the apps behave, which are globally deployed. This is really nice because typically you expect the end-to-end delay for video call to be about 250 milliseconds, for audio about 80, 90, 100 milliseconds. So we are in that ballpark of about 200 milliseconds one-way delay with video. There are, of course, cases where 4% of the cases where the call persists, and we have people with 4% with more than 1 second delay, but they still continue to be on the service and continue to talk. That might mean that they are aware of the fact that they go around that problem by just doing a walkie-talkie kind of way where someone talks and the other guy responds. And I guess in some cases, it's not a bad thing, because if that is the only way you can get your message across, then you would use that kind of latency. You would still do the call on those things. So wrapping it up, we talked a bit about quality. We gather user feedback. So in 11% of the calls, we see dissatisfactory feedback. In almost 60%, they say acceptable, 28% claim it's excellent, which is super cool, because this is mapped to the feedback model is 1 to 2 is dissatisfactory, 3 and 4 is the acceptable, and excellent is 5. So we give explicit weightage to the score of 5. And this correlates kind of with our objective quality on the aggregate, where we see 12% of the calls have objective quality poor, and 73% of them are fair, and 15% is excellent. And as I said, we are a bit, let's say, speculative in this manner, where we speculate things are worse than they are. So we kind of penalize a bit more harshly. So we do see like a bias more towards the fair end rather than the excellent. And we prefer to say that the things were okay rather than claim that things were great and the user complains. So as our models mature, we would be able to tune this a bit better. So that brings me towards the end of my talk. So quick lessons learned. Audio and video device permissions, they should be, in some cases, asked separately depending on what kind of app you build. We've seen some apps where we've seen a lot of permission failures, partly because they were asking for both audio video, and the user, when presented with that choice, either did not know that he wanted to give access to video as yet or not, and would deny permission for both audio and video simultaneously. The other thing that we've seen is the deployment towards turn servers and more towards the TCP support. We've asked a lot of our customers, especially who were not aware of their deployment services. They looked at their numbers and then went back and deployed the TCP turn to see if it improved their failure rates. And we've seen some of that happen. Some of the things that we've been working on our side is to detect crashes and tell the app that some of the pipeline, or there's one-way audio, and maybe they should reset up the connections so that the user does not have to detect them by themselves. User does not have to say, "Can you hear me?" for example. So if you can detect it by yourself, you would say, "Okay, please see if your mic is turned on and off. If not, then we'll do something at our end." So a summary, still participants, we see 2 in a call for the majority of it. Relays, 25% of your calls need a turn server. 80% of the sessions set up in 5 seconds, which we think is a good thing. Call setup failures have reduced over the last 6 months. They're now at 4% according to us. Reasons for failure still remain NATs and firewalls, and about 12% calls fail or drop off because of various other issues, including high setup delay, or just delay or latency and losses in the network. So that is all I have.
Yeah, thanks. That was great. There are a lot of interesting numbers in there. First one is, are there particular metrics in there, if there's only one that you're going to watch that you think is most important?
So typically when a service goes live, we kind of tell them to monitor more their failures. For example, that's the most important thing, to figure out where the bugs are and if the integration works as intended. So it can be like an integration issue with Callstatsio, or in general, there might be some issues that they might not have been aware of. So failures are typical that we monitor more closely, especially when a service comes live. And we have categorization, as I said. We have media source errors, we have negotiation errors, ICE connectivity failure. Some of these also come up when versions of the browsers change, and either something inside the browser change that makes a certain bug appear, which causes some kind of failures. And those happen routinely. Whenever this happens, then you should look at it. When you're a more mature service, you're looking at optimizing both in terms of like what your expectation is in call duration, right? So you want to then measure churn, and you want to see if your setup times are accurate, and if people are using your service more, right? So they're either increase the volume of number of calls or the duration of the calls, and those are the 2 metrics that most people watch for, and then try to correlate that with the user feedback or the objective quality that we measure, so that they want to have higher objective quality as these numbers increase, especially as your volume of the service increase.
Right. What are how do you come up with that objective quality metric that you use? And you mentioned too that you do it kind of in a little bit more of a you judge things a little bit harshly. You said you'd rather be a little bit pessimistic about whether a call is considered poor or fair, right?
Right. So when we were doing congestion control in my previous work, we used to, so when we would do congestion control, you want to see like how much anything varies by. So some of the things that we learned around then was that you don't want to, like, from a human perception region, you don't want to change like your frame rates too often or frame size, where it would be super annoying that you have high quality video, then low quality video, and then high quality again, right? So people would prefer like controlled degradation and controlled like upgradation as well. So we kind of took that to our heart, and we said, like, if you're going to do an objective quality metric, we're going to like look at how quickly these things change. In our API, there are some context that you can provide. So you can say if this is indeed video or is the screen sharing. So there's some bias towards that. And we've been tuning our numbers based on what we've seen over the period of time. So like it's self-tuning, or we're tuning the algorithm to perform better under some certain circumstances. So getting back to the actual measures, we look at timeliness. So for example, I'm speaking, I expect that audio to be heard at the other end. So we're looking at frames propagation time, for example, and how accurately did they get played back, right? So you want to see like it was generated and if it was played back. And the other thing is to see if you have both audio video, if they're being played back in sync. And if there's a drift and it's a constant drift, we don't penalize it as much. We penalize it less. But if the drift changes, if the audio video like timeliness is skewed or changes over time, then we we measure it more harshly, because we believe that people can adjust to audio video being out of sync a little bit constant. But if it varies, then it may be a bit more annoying. So as I mentioned before in the first slides, that we have this annoyance metric, and that we've bunch of things there. And those are the things that we actually consider quite important for an objective quality metric.
That makes sense. That's great. So Eduardo asked us in the comments, what actions should a developer take when a connection disruption happens?
So it depends a lot on what you could do. For example, there are cases where we've been seeing disruptions happening because of loss in connectivity. In some cases, it might be just sufficient to tell the end user that they've lost connectivity, right? So that they don't have to diagnose it by themselves. So in our API, we have a thing called stats callback, where we do say what is the state of the connection, not only to the signaling server, to Callstatsio, but also the peer connection. And we have things that we augment from the fact that we have high losses or high latencies. We start to say like this connection is not broken yet because your ICE connectivity is still there, but it's getting worse, right? So if you had a traffic light or something similar, or which goes amber, that would be one way. The other way would be that which you could do more presumptuously, is that when you lose connectivity, you try to reestablish connectivity. That may mean that you like redo the connection and see if you can get a connection back, rather than have the user like reload the page. And that might help as well, because if you can indicate to the user that you see connectivity issues, show the amber light and say that you're like trying to reestablish connectivity, then that exposes information to the end user, who may have a better user experience and may not even write a support ticket, right? Because he thinks that you know what you're doing. So
right. If you have bad news, give it to the user, and they're going to be more comfortable with it about
right.
that. Yeah.
They might argue, like some might say, like over a period of time that I've seen this happen like 50 times, and you guys need to fix your stuff, right? But then you get only one of those 50 emails and not all those 50 emails.
Right. Yeah, I thought it was interesting you mentioned, I think, that the largest calls that you see are 20 to 30 people using call stats, and that number, I believe you said, or it's been my observation too, that others are getting more confident in doing larger size group calls. I presume that's mainly being done over SFUs rather than a direct peer-to-peer connection between.
Sure, definitely. Yeah.
And so is the growth in group calls based on those improvements in media server options for people, and what other best practices should developers consider if they know that they want to have a large number of participants?
So last year when we had fewer customers, a lot of them used to be like mesh calls, so like people calling each other without a central server. Over the last 6 or 8 months, we've seen more systems using SFUs or media servers, and there's several open source ones without naming any, and we've seen a tremendous growth in that place. So we've seen companies which had a deployed WebRTC mesh actually start to integrate SFUs into that mix, and opportunistically starting to deploy some of them. And some of them have already like stopped their service, had a flag day, moved all of them to like an SFU the next day. And that's a good thing in terms of where people are trying to push the limit on the number of people in a call, right? So the largest one that we've seen till date was one instance of a call which had about 100 participants, but only one. But typically what we've seen, few more of them, like less than 0.5%, or have been around like this 20-30 number. So in best practices, what we've seen is people actually use a media server, configure it very well. Some of them have even experimented with simulcast and I think what they call last N, where you see a bunch of subset of people, not all of them, right? And that with so there are these two things that we've seen that has happened. There are several open source versions with a lot of good community surrounding them. So there's a lot more out there than what we have to offer to them. So for example, they already know what kind of media server they want. We have integrations with some of them. They go and ask the community like how to configure those correctly and use them. And when they come on to Callstatsio, it's either two-step process. They already have that integration, or they do that integration. And typically, there's some engineering work that goes around that typically when they start to see issues with scalability. So if they have like one media server that scales to a certain amount, and if their traffic is under that, that is super, but you expect them to grow, and that's when we start to see more issues. We've seen that happen with some of them, but I would say most media servers can take a lot of simultaneous capacity. And there are good AWS proffers like really expensive servers as well. So either you can throw money at the problem or build scalability. So
right, that's great. We have time for just one or two more questions, I think, and then we should wrap up. But this has been really interesting. I thought it was interesting. You mentioned and this may be a factor somewhat of the data set and the increased size data set that you have, but the calls that fail to set up going down to 4%. Also, the other number that stuck out to me was that the majority of calls set up in less than 5 seconds at this point, which that also seemed to me, based on our experience, that's getting better over time as well. So I presume that in general, you're seeing all of these stats are getting better over time. Do you have a way to compare them to non-WebRTC based solutions, more traditional video conferencing solutions? What are the I presume WebRTC is still lagging a little bit behind that in some of these metrics, at least. Where do we need to get to say that it's equivalent?
I think that equivalence is kind of there today itself. It's just speculative. A lot of people say that so without very hard numbers, we don't have those,
right.
But since we don't have deployments to those things. But apart from people claiming that the numbers that are provided by traditional conferencing, and I'm talking about video conferencing, not like POTS or some other telephony stuff, but like traditional video conferencing, these numbers are, I think, are comparable, especially in terms of setup times reducing. That's been like a major effort both from Google and Firefox in trying to improve that, and we've seen that with the other browsers as well, that they've spent a lot more time in two aspects, like setting up the call very quickly and also increasing the bit rate very quickly. Like it used to be a bit slower. Today it's a bit more rapid in getting like the first few frames out, better quality, and so on and so forth. The other thing that we've seen is the emergence of simulcast, like a lot more people working on it, a lot more people trying to like optimize the video quality in that sense. And I think with as soon as we see a bit more of simulcast, we would be at that point comparable to the likes of Skype and similar. I think the places where we've seen like problems have been with echo cancellation and gain controls and things like that. And I think that as well has seen remarkable improvement in the last year. So I think in general, things are improving well, and in some cases quite rapidly. So whatever I state today is already like a few days old, right? And things might have changed depending on if a new browser released in that period of time.
Right.
So
yeah,
so
we'll be editing and posting this video to YouTube, and by the time I get it posted in the next 24 hours, some of these numbers will have changed already, right?
Definitely, yeah. And if a new browser releases in that period, then all these numbers have indeed changed.
Absolutely. Excuse me. One or two other questions here from our users. Uziel asks, is there any connection problems or failure that's more related to a specific browser type?
Typically, this can happen when a new browser version comes up. It's very hard to say if a specific one is at fault. It also depends a lot on our testing. I think a lot of people test with one particular browser and forget the other. And when the other browser changes something, then it causes some heartbreak in terms of like, oh, this changed. It became better, but I didn't realize that things changed. And we see that happen quite often where a new feature comes up. There are features that one browser has and the other is trying to catch up, and like vice versa. So there's a combination of that. I think a lot of people are spending more time testing against all these browsers. I think we've seen harnesses being built, the services that do that for you, and so on and so forth. So I think there's a lot of effort being put in there. And I think typically this is just blindsidedness, right? So we don't test for something and then something changes, and that's when one browser is maligned. But I won't say I think the browsers are quite comparable in terms of some performance. In some areas they're different. And I think over the next few months, we would see them converge on a lot of those features.
Sure. Yeah. Naturally, there will be some differences since things are still changing in the WebRTC standards and in the space. Which brings to one question I wanted to make sure to ask you. Is there anything coming up in the WebRTC standards that is particularly relevant to call quality or metrics that we should be looking for?
So in terms of metrics, I think the better thing is that the GetStats API is maturing a lot better now. We're putting a lot more effort in getting that standardized and implemented across browsers. The good thing I've heard is that Google's going to change their GetStats implementation in the coming few versions. I can't speak for them, but that's the indication I got. That's actually good because we've been maintaining slightly different code bases to make sure that the two APIs kind of work together. That is one aspect of it. The other is that all the vendors have been working a little bit more on exposing statistics. So there's a little bit more demand for more accuracy in terms of what are we trying to get out of the system. So we've moved beyond the basic metrics, and we're talking about more complex metrics, especially in terms of connectivity failures. We've seen Google introduce some of those ICE connectivity checks and consent-related metrics, which have been discussed also on GitHub for WebRTC stats. That's some things that we've seen. I think there are a lot of bitrate congestion control is changing. I think there's move towards standardizing both the format of the congestion control feedback and also trying to get the best practices from the other proponents into something that would make sense. So I think that would make call quality better, both in terms of congestion control and the feedback messages.
Yeah.
In general, I think with the object model, we've gained a lot more And I think people should start to move and use the object models as they become available. That gives you better control over the quality of experience. And at Callstats, we are working on that as well. So like we can, the next few features that we are announcing in the coming months would be more towards the management of a particular peer connection, where our customers would give us some guidance on what they want, and then we would try to do that opportunistically, as we do for the stats. That if we observe something, we would go and tune those configurations or settings for those objects. Today, that would have been a bit more difficult because of the SDP, and not like you don't want to change SDP. 3 people do not want to change the SDP simultaneously. So that would make life a bit more easier in some sense.
That makes sense. Yeah, it's good. So definitely look for start using the object model more, and it'll help us on the metric side as well. So
yeah.
one final question here, and this is perhaps the most challenging question that always comes up in WebRTC. Eduardo asks us about having the best experience possible, and that, of course, everyone wants to have an HD type of experience, regardless of the connection that they're on.
Yeah.
How much, so, to his question about how can we provide that experience sooner, and I would add on to that to say, how much can developers control the quality, or are they really just limited by the internet connecting with other participants?
So there, I think a lot of it goes down to what kind of application the WebRTC thing is going to be tied to. There are things where you could manipulate it, where you could say, oh, I want resolution over frame rate. And then there are other places where you would say, I would prefer frame rate over resolution, right? And then there's a balance in between where you say, like, I want decent frame rate and decent resolution. So I think this is the knobs that we do have. And these are the current abstraction that we need to have, because I think the application developers can tune these things, and that's good. The browsers can tune their congestion control to those things is also good, because they need to have like some kind of thing telling them that, where should I spend more energy, either in generating more frames or like having a high definition quality. So I think the trade-off is already available. What the developers can indeed do is measure over a period of time, right? So for example, you make a call and it fails, or you don't get the quality of experience you want. Then rather than setting up the call with the same configuration pattern, you would want to like change that a little bit. And this is also a service that we provide, right? So we collect data and we can like diagnose across services. So if a user made a call on Hangouts, for example, and then made a call on Skype, you would easily say if there was one monitoring service, they would basically be able to like get that data. And when you make a call on the second service, you would already have that information there to put into your objects. And I think that is where the learning would be, that the application developers would learn both based on context, which is like what app are you building, and then the specific context the user is in, like is it wireless or not, and things like that.
Right.
So I had one announcement, like to make. Since we've been working on the JavaScript most of our time now, we are announcing a REST API soon, so that people can take that REST API and build it into their mobile/SFUs or whatever infrastructure. If people are excited or interested in having call stats in their mobile/SFU or network equipment, they can like send a message on Twitter to us or write an email to Varun at Callstatsio, and we'll get back in touch with you. The REST API should be available in the forthcoming weeks. So we hope to expand this measurement platform beyond its current JavaScript bindings.
That's great news, and thanks for sharing that with viewers here on the Real Time Weekly show, and we'll definitely share that with our readers as well. So congratulations on that REST API announcement. And yeah, I think that'll be super useful to this. So look forward to trying it ourselves. So anything, I just want to thank you again for the time. And this it
was a pleasure.
Went a little longer than I planned, and I know it's into the evening for you. I hope that's okay, but this has been really informative and definitely enjoyed it. So Thanks again. Is there anything else, anywhere else you want to send users to learn more about Callstats?
I think there's a lot of information today, especially like your Real-Time Weekly is pretty useful. We actually learned quite a lot from that because we can't keep up with the news ourselves. So having someone like Indeed like summarize that information is good. I think Arnaud also runs something similar in terms of, I forget what it's called right now. If you do, then you can holler for that. But that's also another useful like RSS feed, I would say, that gives us information. I think it's called WebRTC Weekly, or this is Real-Time Weekly. I forget what the other one's called. But,
well, you know, there's WebRTC Weekly, there's Real-Time Weekly, and then Arnaud has the a Twitter account that's very good as well with web news. So yeah, there's a lot of great sources like that, and then of course you'll have a lot of great resources on callstats.io. So great. Well, I'm going to wrap it up here and just say, again, thanks to everyone who joined us today. Thanks again to you, Varun, for being here.
Thank you. It was my pleasure.
And if you want to learn anything else about WebRTC development or our sponsor, WebRTC.Ventures, check us out at WebRTC.Ventures. You can sign up also for Real-Time Weekly at realtimeweekly.co to find out more about upcoming webinars like this one. So thanks again, everybody, for your time today.